Hello and welcome to Train Signal. You're watching the A-Plus Technician Configuring and Troubleshooting Networks video. This is part of the Train Signal Fast Track CBT video, CompTIA A+. In this video, our overall goal is to help ensure that A-Plus technicians can comprehend and troubleshoot networks. To do this, we'll cover topics like network types, core network components, IP addressing, DNS, how to configure your network, how to configure your browser, how to share network resources, and how to perform preventative maintenance on your network. Now, before we get started, we're going to talk about the A+ exam objectives for the IT technician exams, remote support technician exams, and the depot technician exams, and how these relate to our video. So first off, let me point out that in this video, there's really no topics that relate specifically to the depot technician exam. And that's because I guess they assume that a depot technician isn't going to be working on the network very much. So the objectives that we cover here specifically are for the IT technician and the remote support technician. So we talk about the fundamental principles of networks, and specifically a lot of different protocols or applications like TCP/IP, SMTP for email, IMAP, HTML, HTTP, HTTPS, Telnet, FTP, and DNS. We talk a lot about different technologies for networking like dial-up, broadband, ISDN, infrared, Bluetooth, cellular, and voice over IP. And this is the same list of topics for the remote support technician exam that's shown right here in red. Then we go on to talk about specifically installing, configuring, and optimizing networks. Topics like scripting support in your browser, network connectivity, network cards, client options for connecting to Windows networks, network models, permissions on network shares. We talk about using tools and diagnostic procedures like ipconfig, ping, tracert, NSLookup, cable testing devices, permissions, firewalls. And it's the same or a similar list of topics for the remote support technician exam. And then finally, for the IT technician, we talk a little bit about performing preventative maintenance of networks, including securing and protecting your network cabling. All right, so let's get started by talking about different types of networks. We talked about a number of these in the A+ Essentials networking video, but let's start off by talking about the LAN. The LAN's your local area network. That's where your PC is connected. That's where your laptop, your printer, all those devices are connected. The LAN is generally inside your building, and it might connect to other buildings that are right around you. But once you get outside of your LAN and you connect to the internet or to some other form of wide area network like a private network, you're talking about a WAN, or the wide area network. If you live in a metro area, some cities, municipalities, some large corporations might have their own MAN, their own metro area network. If you're using Bluetooth, like a Bluetooth headset, you can have a PAN or a personal area network. With SAN, the storage area network, you can connect your disk arrays directly to your servers, and you can use fiber optic connections to transfer data at high speed between your servers and your storage area network. This allows you to have one gigantic disk array, if you will, and share it amongst all the different servers. Then you could also have a BAN, or a backup area network, if you chose to. This is a separate network used just for backing up your data. All right, now let's talk about ISDN. ISDN stands for the Integrated Services Digital Access Technology. This is a switched network that you would think of like dial-up, because you do dial the number of the ISDN connection you want to talk to. So it is like dial-up, but the difference is it's a fully digital dial-up network. So compared to analog networks where you dial up with your analog modem, with ISDN, when you dial up, it only takes just a second or two to connect to your remote site, and you can get much higher speed bandwidth and much more reliable bandwidth than an analog dial-up network. ISDN can both be used for voice or data calls, and it comes in a different flavors or different capacities in the United States. The first one is called a BRI, or a basic rate interface, and a basic rate interface is two 64K B channels plus one 16K D channel. Now the D channel is used for management and the B channels are used for your data or your voice calls. So two B channels could support two simultaneous voice calls, or you could bond them together or use them individually for data. So you could get up to 128 kilobits of data with an ISDN BRI. Then you have a PRI. A PRI is 23 64K channels, B channels, and one 64K D channel. So a PRI is similar to a T1 circuit, but a T1 circuit is a point-to-point, statically set up connection. Whereas a PRI, you could dial up 23 different remote ISDN connections with a PRI. Of course, you might have to pay, or you will have to pay long distance if you're calling outside of your calling area. ISDN has lost popularity a lot when it comes to data, simply because the internet has taken place of a lot of different types of switched networks that used to be more popular. ISDN circuits are a form of WAN technology, so when you dial up an ISDN connection, you're creating a wide area network connection. All right, now let's talk about broadband. Broadband is a type of WAN circuit that runs at high speed to connect homes and small businesses primarily. Broadband is kind of a general term. Usually when people are talking about broadband, they're talking about their DSL line, their cable network, or maybe their satellite connection that they use for data. So when people talk about, do you have broadband access, they're talking about some kind of high-speed network access, typically cable or DSL, maybe even wireless. But it's a form of WAN connection, and it's used typically to connect homes and small businesses. All right, then you have dial-up. Dial-up, or analog dial-up, I should say, is what people think of when they think of older, slower internet connectivity, but dial-up can be used for any kind of data access. It's a low-speed WAN circuit on an analog phone line with a modem. So here's a picture of a PC connected to a modem, dials up through the regular telephone network to an internet service provider. That's a provider that provides you internet access so you can get to the internet. Many people today have gotten access to broadband connectivity like DSL or cable, and they've gotten rid of their older, slower dial-up connections. Right, then there's wireless. When I say wireless, typically I'm talking about 802.11, the 802.11 wireless networking standards used to connect PCs to a wireless access point, or a PC to a PC, laptop to laptop, laptop to access point. There's a number of different standards when it comes to 802.11. There's 802.11a, b, g, and n. N being the newest and fastest and with the best range, but also still in sort of limited availability and not a lot of standards with N. Wireless networking is used to connect your laptop, like I said, to your wireless access point. So say at your house, you could sit out at the pool and you could surf the internet from your laptop over the wireless network back to your access point, which is usually also a router to connect to the internet. You can also use wireless networking for WAN circuits, and you could do a point-to-point wireless link over a long distance. So you can get point-to-point wireless gear that can go a number of miles even, but you have to make sure you have a clear connection between the 2 points. I've used it personally to connect buildings. So say you have a campus area network, but you have, say, asphalt or concrete in between all the buildings, but you still need to connect them and get them up as quickly as possible. You could hook up wireless between all the buildings and connect them together using wireless networking. All right, then there's infrared. Infrared forms a PAN, or personal area network. It's also called IRDA, and infrared is a low-speed line-of-sight connection for data transfers, such as synchronizing your PDA with your PC or printing from your laptop to your IRDA printer. And infrared uses light, so it's like the remote control on your TV. You have to have direct line of sight and point the device at the printer to print out using infrared. There's Bluetooth. Bluetooth, like I said, is what you use with your Bluetooth headset with your cellular phone. It forms a PAN, and it's a short-range wireless network that uses low power. It's also used between PDAs and laptops or There's a number of different newer applications for Bluetooth. Next up is cellular. Cellular is a radio network or wireless network. It's used for voice and data. Towers are spread out among the city and throughout the country really to create this cellular network. Now the area that's connected underneath a single tower is called a cell, and cellular is a type of WAN or wide area network, and it has various uses for data. You can check your email, say with your Treo or your BlackBerry. You can get cellular data cards for your laptop so that you can connect to the internet. There's a lot of different data applications for cellular, as well as the common cell phone that everybody's already familiar with. All right, another technology is voice over IP. Some people call it VoIP. With voice over IP, your voice call is translated into data so that it can be sent across the data network, usually some kind of WAN, and there's a number of benefits to doing this. One of them being you could have a soft phone on your PC, so you have a phone built into your computer that connects over the data network to allow you to make voice calls. You could have a computer that's running as a phone system that keeps your voicemail, and it could also integrate your voicemail into your email. There's a lot of great things you can do with voice over IP. Commonly, it's been used to reduce the amount of money spent on long distance charges. So large companies, instead of paying long distance between all their multiple sites to make phone calls, they put in a voice over IP network and they reduce all that long distance between their multiple sites. It's an amazing technology, and it just continues to grow and grow. All right, so which of these different types of networks do you use every day? I think if you think about it for a little while, you'll realize that you or someone you know uses just about all these different types of networks we talked about every day. So the first one is cellular. Most people today have a cellular phone, so that's an example of cellular. That's an easy one. The next one is Bluetooth. Maybe you or someone you know has a Bluetooth headset that they use to talk on their cellular phone. Or if not, I'm sure you've seen one being used in the grocery store or in a restaurant or somewhere. Might have been annoying you, or it might have been a real convenience if you've used one yourself to make a call without having to hold your phone up to your ear. Wireless. Maybe you have a roaming laptop that you bring into the living room so you can do work. Maybe you take your laptop to the local coffee shop, or maybe someone you know is at the coffee shop surfing the internet on their laptop. DSL or cable. Many people today have DSL or cable or some other kind of high-speed networking in their home or a small business, and so there's an example of broadband. We talked about voice over IP. There's a popular service called Vonage, which you have probably seen advertised on TV. It's a voice over IP phone service for your home. Replaces your local home phone service with a voice over IP connection that uses your internet connection. I'm not advertising that company, but it's a well-known, popular company that uses voice over IP for a very consumer-oriented service. So those are some of the common networking types that we talked about, and just some examples of how you might be using them already every day. All right, so let's talk about networking terminology. So we have a lot of acronyms here and a lot of techie talk. The first one is Internet Service Provider, or ISP. Anytime you connect to some other company to get on the internet, that's an ISP. So at my home, I have Roadrunner is an example of an internet service provider. Yours might be AT&T. You might have Verizon. Many of these large telecom companies are internet service providers. There might be other small mom and pop or small companies that provide internet service. Those are all examples of ISPs. TCP/IP, or Transmission Control Protocol / Internet Protocol. This is the protocol that's used by the internet and just about by every network in use today. TCP/IP is the protocol that is used on the network to send and receive just about all of our data. TCP/IP might also take the form of UDP, and in that case it's UDP/IP. There's also other types of IP traffic like ICMP traffic that uses an IP network but has other purposes like management. Just about every application we'll talk about in this video, and every application that has to do with networking, is a TCP/IP application. There's IPX SPX. This is a protocol that would be an alternative to TCP/IP. It was used by Novell NetWare before NetWare 5, but it's really lost out in popularity, and even Novell dropped the use of IPX SPX for their NetWare network operating system. All right, there's NetBUI and NetBIOS. These work on LANs only. They don't go across a wide area network, and they're used for peer-to-peer traffic. So say you have two PCs, you want to share files between them, you could use NetBUI/NetBIOS to communicate between those two computers. There's AppleTalk. AppleTalk is used on Apple computers only. It's a very chatty network protocol, meaning there's a lot of traffic that goes on between the Apple computers to make it happen. It uses CSMA/CD, which is different from the standard Ethernet protocol. It has variations like Token Talk and Ether Talk, and Mac's newest operating system uses TCP/IP. So even AppleTalk is pretty much gone by the wayside. All right, then there's DNS. And we're going to be talking about DNS in a few upcoming slides. DNS is the domain name system. That's what translates your IP address to a name. All right, then there's WINS, or the Windows Internet Name Service. This is similar to DNS, but it's an older Microsoft solution for corporate networks, and it's been replaced by DNS with Windows 2000, but so many applications still rely on WINS that usually today it's still configured in many corporate networks. There's operating system network entries for TCP/IP. So this isn't a technology or protocol. What I'm pointing out here is that on your computer, when your computer connects to your network, there are certain entries or pieces of information that your computer must have to connect to the network. First one is a default gateway. A default gateway is where your computer goes to access another computer that's not on your local area network. Typically, your default gateway is going to point to your router, maybe that goes out to the internet or to some other private network. Of course, what isn't listed here but is very important is your IP address. Every computer has to have an IP address on the network. Every computer has to have a subnet mask. The subnet mask goes along with the IP address, and that's how the computer knows what's local and what's remote. The default gateway, by the way, is an optional parameter, but if you don't have a default gateway, you'll never be able to get off of your local area network. There's DNS servers. DNS servers are where your computer goes to look up names and translate them into IP addresses. You might configure WINS servers on your computer so they know where to go look up WINS name entries. Hopefully you're getting your IP address, default gateway, subnet mask, DNS servers, and WINS server information all via DHCP. That's the Dynamic Host Configuration Protocol. This is what hands out IP addresses so that you don't have to go into each computer and statically type in that information. Of course, you could statically define IP addresses and not use DHCP, but DHCP really makes things convenient both for the end user and for administrators. All right, then there's SMTP. SMTP is the Simple Mail Transfer Protocol. This is used to send mail only. And it uses port 25. So it's only used to send mail. So if I'm going to send mail from my PC to the mail server, I use SMTP. If the mail server needs to send that mail to some other mail server, it's going to use SMTP. Now, when I go to receive my mail, I may use IMAP4 or POP3. These are mail client protocols, and they're used only to receive mail. So when I go to my mail server and check to see if I have any new mail, I'm going to use IMAP4 or POP3. And these use ports 143 and 110 respectively. Now, if you're using Microsoft Outlook, you might use RPC instead of IMAP4 or POP3. RPC is used to connect to your Exchange server from your Outlook client, and RPC stands for Remote Procedure Call. Right, then there's HTML. HTML is the Hypertext Markup Language. This is the language that web pages are written in. So it only creates the text, and it references the graphics and the other dynamic content. So if I go to say I open my web browser, it brings up my home page there. I go over here to view or page, and I go down to view source. This brings up the HTML. This is HTML right here, and this is what makes up that web page. This is the text that references the graphics that make up that web page. All right, then there's HTTP. HTTP is the Hypertext Transfer Protocol. This is the language that's used to request and send HTML pages, graphics, files. It uses port 80, and IIS is an example of a web server. So the web server is an HTTP server, and it sits there and listens on port 80, waiting to receive a request for an HTML web page. Now, for complete training on web servers, if you're interested in learning more about IIS, the Microsoft web server that's built into Windows Server, you can go to this web link here at trainsignal.com. Right, next up is HTTPS. This is HTTP Secure, and it uses port 443. HTTP Secure is used to encrypt data, say, between you and a website where you're buying a product or a service, or maybe between you and your bank. So it's a version of HTTP, but it's secure, it's encrypted, and it uses a different port. All right, then there's SSL. SSL stands for Secure Sockets Layer. It's used to encrypt HTTPS web pages and other network traffic. There's Telnet. Telnet is the command line shell that you can use over the network. It's an unencrypted command line shell or protocol, and it uses port 23. So say I want to connect to my router and get a command line prompt. I may use Telnet, but it is unencrypted. Now for an encrypted and more secure version of Telnet, you can use SSH, which is Secure Shell, and it's a command line shell over the network, just like Telnet, but it uses port 22. And there's also SCP, which is Secure Copy, where you can securely copy encrypted files over the network. There's also SFTP, or Secure FTP, which is similar to the File Transfer Protocol, but an encrypted version of it. So the File Transfer Protocol, or FTP, uses port 20 and 21. It uses both ports, and it's used to transfer files over a network unencrypted. All right, so that's our networking terminology. So now let's talk about some core networking components. Now these are components that everyone who works on the network or works on PCs or servers should be familiar with. So the first one is LAN. On the LAN, your components are, you have your switch, you have your NIC or your network interface card, and you have your cabling. So what makes up the LAN is the network interface card that's on your PC or laptop or your laser printer, and it goes from there to the cabling that's in the wall, and then it goes over to the Ethernet switch in some wiring closet somewhere. From there, your traffic goes maybe to a router, out to the WAN or to the internet. That's next here, router. Or maybe it goes to another server that's on the local network. So I have here also servers. Servers serve files, email, web pages, could be just about anything that servers serve up. Servers can be dedicated to a single task or a non-dedicated task. So I can have a single Windows 2003 server that's running Exchange, IIS, file sharing, print sharing, and a variety of other things. Or I could have a single server that just runs email. That's it. Then you have your clients. Those are your PCs, laptops. And then you have your network resources. So for example, you have a shared printer. You have shared files, shared applications like web servers, or other shared peripherals or applications. For example, you could have network faxing, network scanning, or other things. A few notes here that I wanted to point out. The first one is that today routers, or I should say switches, routers, access points, firewalls, and even print servers many times come integrated all into one box. So all these different functions that we talk about in training videos or in books, many times for home or small networks, come integrated all into one box. So it can make it a little bit confusing to understand all these different separate devices. But if you go visit a enterprise network or a large or even medium-sized network, they will have all these components separate. So they'll have separate access points, separate switches, separate routers, separate firewalls, all individual boxes, and it's much easier to visualize that way. And a common question I've seen people ask when it comes to networking is, when do you need a router? Well, you need a router anytime you want to connect to a wide area network, such as the internet. So let me rephrase that. You need a router anytime you want to connect to the internet, because that's how most people, or that's what most people need to connect to, is they need to connect to the internet. So you need a router anytime you want to connect to the internet, or anytime you want to connect to a network that's not on your local area network. Some people also subnet their networks. That means they break up a large network into smaller networks, and between those networks they put a router. So it could even be in one large building. Say you have a 10-story office building with 100 PCs on every floor. Well, you would subnet that out into different networks, and you would use one or multiple routers to connect all those together. All right, the second question I get is, when do you need a switch? Well, you need a switch to form a local area network. So anytime you have more than two PCs that you want to connect together, you need a switch in between those devices. So say I have two laser printers, 10 PCs, and one server. I want to connect them all together to form a local area network, allow them to share resources, share files, get email from the server, send print jobs to the printer. Then I need a switch. That switch is going to connect to cables, and those cables are going to go to the network interface cards on all of those devices. All right, so now let's talk about IP addressing. We talked about TCP/IP. Here we're just talking about the IP portion only. IP you can think of as the source and destination for every packet on your network. That's what it's used for. It's used to identify the source and destination of every packet. So if you think of an envelope that you mail a letter in, on the outside of the envelope that you drop in your local mailbox, you have a recipient, the person who's going to receive the letter, and you have the sender, or the return address, right? So the sender is the return address up there in the top left-hand corner. The recipient is right in the center of that envelope. That's where you write them. Each one of them has their own address, and that's how the post office knows where to send that letter to, and if no one's there, they know where to return the letter back to. Well, IP addressing works the same way on an IP network or on a computer network. Every packet has a source and destination, and IP is what takes care of that addressing. So an IP address must be assigned to every network device on every network in the entire world. An IP address is made up of what they call 4 octets of 8 binary numbers each. So basically this is translated into decimal with the range of 0 through 255, dot 0 through 255, dot 0 through 255, dot 0 through 255. And as an example, 1.1.1.1, that's a valid IP address, perfectly valid. Or 192.168.1.100, another example of an IP address. Now the network and the node portion is divided by the subnet mask. So besides having this IP address here, you also need a subnet mask. And the subnet mask tells your computer what devices are on the local network and what devices are on the remote network. So an example subnet mask is 255.255.255.0. Now in the past, IP addresses were classified into classes like A, B, C, D, and E. And you can still take an IP address and tell what class it's in by what number it starts with. However, today we've really abandoned the concept of classes, and those classes really aren't used much anymore except for some certification tests. Now, if you'd like to learn more about subnetting, here's a couple great resources. The first one is a website called learntosubnet.com, and on this website they have some training videos on subnetting. And then here's another website here that is great for downloading some IP subnetting charts that can be used to perform IP address subnetting. All right, now let's talk about public versus private IP addresses. There's a standard out there called RFC 1918, and this standard defines these private IP addresses. Now, the catch with the private IP addresses is they cannot be used on the internet, on the worldwide internet, and the good thing about them, though, is that anybody can use whatever private IP address they want for their own network. So I could use 192.168 1.1 for my network, my IP address on my computer. You could use it for your computer over at your house, and it doesn't matter. Everybody can use those same blocks of IP addresses. But when the traffic goes out to the internet, it's translated into a real public internet IP address. So these are some blocks of private IP addresses that people use for their home networks and companies use generally for their internal networks that aren't directly on the internet. And then when those devices need to access the internet, they're translated to real internet IP addresses. All right, so now let's talk about DNS. DNS is the domain name system, and it's a core piece of the internet and just about every private IP network. Now what it does is it maps IP addresses to IP address names. And generally it's mapping names to IP addresses for most of us end users. Now without it, how would you know how to get to your favorite website? Do you have the IP address memorized to your favorite website like trainsignal.com? No, you don't. None of us do. We don't know IP addresses. We know domain names. So say you wanted to go to comptia.com. www.comptia.com. You type that in your web browser. What happens is your PC sends that request to your DNS server. Your DNS server looks up the IP address. So it got 200.2.2.2 here, returns that to your PC. Then the PC actually makes the real request over to the CompTIA web server, which is at that IP address. So that's what DNS does. Now, if you'd like to spend some time learning a lot more about DNS and going into real detail, TrainSignal offers a great training video specifically on Windows DNS. However, that's not something you need for the A+ exam. I just wanted to point that out if you need that for future reference. All right, now let's talk about DNS domain names and how they must be unique. I can't have the same DNS domain name as someone else. If trainsignal.com is already registered on the internet, you can't go and register it and use it yourself. So DNS domain names are broken up into this hierarchy. So at the very top is the root, which is called dot, but none of us really think of that. None of us really use the dot. And then from there it trees down. This is like an inverted tree. So up here would be the branches and down here are the roots. But this tree is upside down. So here at the next level you have, for example, org, com, and biz. Most of us are familiar with com. So from com, it goes down to things like eBay, TrainSignal, Google, Amazon. And then from there, it goes down to www. Many of these might have an FTP or some other domain suffix down here like mail or DNS or some other name. But you get the point here, how this is a tree organization. So from .org goes down to CompTIA, then down to www. Up here, there's also many, many other domain names like .mil for the military or .gov for the government. Now, if your DNS resolution isn't working, you won't be able to ping, telnet, or use your web browser to connect to any named computer or server. You could, of course, use an IP address if you knew the IP address when your DNS is not working. Now, resolved DNS names are cached on each PC and server. Now, you can view this cache with this command, ipconfig /display DNS. So let's give that a try. I'm going to go to the command prompt and type ipconfig /display DNS. Oh, I got a lot of information there. Let's just look at the last one because it's all the same concept. Basically, at some point, I went to this website called c6statcounter.com and it had to look it up with my DNS server, and it resolved it to this IP address here, 67.15.56.73. So it's going to hold this in the cache for some time, and if I don't use it, it'll take it out of the cache. So if you go up, you can see there's a number of other websites that I've visited, and many times, even if you just go to a single website, many different websites will have to be delivered or looked up because of the ads and all the graphics and everything that make up a single website. So let's say I wanted to get rid of these. Maybe some of the IP addresses have changed, and I know that because I went and I changed the IP addresses. So to get rid of these cached DNS entries, I can do flush DNS. And this cleared our DNS resolver cache. If I go back up twice and I do show DNS or display DNS, it tells me that there's only a couple entries in my DNS cache because I cleared all those other ones out. All right, now the job of resolution is shared across the internet by hundreds of thousands of DNS servers with the major domain suffixes, and there's 13 root servers. So like the .com, the .mil, all these different servers, the major suffixes, those major suffixes are stored across 13 root servers. Now a DNS zone is part of the entire DNS namespace. Inside a DNS zone, there are various types of records, each serving different purposes. For example, an A record is an alias, and it's what points to a name. It's what points a name to an IP address. So say I set up a DNS alias in my local DNS server called PC1. Then I could point that to an IP address. That would be a manual alias record that I created. All right, then there's an MX record, or a mail exchange record. This is what's used so that you can locate your mail server for that domain. So if I send mail to David at trainsignal.com, that's just an example of a made-up email address. My mail server would go to the DNS server for trainsignal.com, look up the MX record or the mail exchange record, and then send that mail to the IP address of that MX record or that mail server. All right, now every computer still has a host file. A host file is a static text file located on every computer, and if DNS is not configured, this is a static text file that could be used to look up names to IP addresses, and it's located in this path right here. So let's copy that. Let's go open that up using Notepad. So let's see, if I go to my computer, go to the C drive, Windows is my system root. Then if we go over and we find, where is it? System 32, drivers, etc. And it's not a text file. We have to look at all files, and it's called hosts. And there it is. There's our example sample host file used with Microsoft Windows if DNS is not configured. Actually, it's used really before DNS. So if you put something in here like trainsignal.com and you send it to some other IP address, when that website was looked up, it would go to that IP address before it went and it looked it up in DNS. All right, so now let's talk about network connectivity. Now, before you can use network tools and applications, you must have a functioning network adapter. You could have a wired network adapter, so your Ethernet cable that plugs into the wall or to the switch, or you could have a wireless network adapter, so you're using some sort of wireless adapter to talk to a wireless access point. So now let's look at how to perform the following on both a wired and wireless network adapter. And this is taken from the A+ exam objectives. So what we want to do is establish network connectivity, install and configure network cards, obtain a connection, configure client options and network options, and then configure some other network options. So these are sort of generic things that you would want to do on a wireless or wired adapter. So to do this, I'm going to demonstrate by going to Start, Settings, Network Connections, and I'm going to click on my local area connection. All right, and what I can do on here, since this is already created, let's bring up our network connections, all the different network connections that I have. And what you can see here is my local area connection has the network cable unplugged. So what I'm going to do is I'm going to pause the video, I'm going to come back, and I will have plugged in my network cable so that we can configure this new local area network connection. Okay, I'm back, and I plugged in my Ethernet network cable on my wired network adapter. By default, this is called my local area connection in Windows. So when that happened, it said connected over here because it knew that it had been connected to the switch. And I got a link light next to the Ethernet cable where I plugged it in on my laptop. And I got a link light over on my switch where the network cable's plugged in. So now that I have that, I can scroll over here. I can see the type of device I have. I have this Realtek Ethernet adapter. And if I go and I right-click on it, I can go and do things like disable it. I can see the status. I can do a Windows repair. Windows repair is great for troubleshooting. It disables the adapter, re-enables it, and it goes through full DHCP and basically a restart of the adapter, if you will. I can rename it. I can call it My Local Area Connection, or I can go into Properties. So let's go check status first. This shows us the status of the adapter. It says it's connected. It's been up for 10 days. It's got a 100 megabit connection. So that's 100 megabit Ethernet. And here's how many packets it's sent versus how many it's received. I can go into support, and you can see that the IP address on this adapter was assigned using DHCP. It has a subnet mask that it was assigned with DHCP and a default gateway. If I go into details, I can see that I also have a DNS server IP address, and that my DHCP lease is a temporary thing. It will expire here soon, coming up on 3:30 in the next day. 24 hours it looks like it will expire. Here's my physical address. This is my MAC address for this Ethernet adapter. Now at this point I can do a repair, and let's do that. So it disables the adapter, re-enables it, and it goes through and it tries to connect problems and basically restarts the adapter. We can go back to the General tab, then click on Properties. All right, and this is where I can configure different protocols on the adapter. For example, you see here I have TCP/IP configured. If I double click on that, this is where right now I have it configured for DHCP, but I could choose to statically define my IP address, subnet mask, default gateway, and DNS servers. I like DHCP. I like automatic for both IP address and DNS. If I go into advanced, there's some other advanced settings in here. This is where I can go in and I can statically define some DNS servers. I can go in and configure my Win server, or I can do other TCP filtering. Here I can also go into authentication if I want to use an advanced security authentication mechanism. I can go in and configure my Windows firewall that's built into Windows. Here I can turn it on or off or configure exceptions. I can use internet connection sharing. This is where I share my internet connection or my network connection with other computers on my LAN. All right, so we showed you how to establish network connectivity, installing configured network cards. That's something you would have to, try on your own because that's a hands-on thing. Many PCs today, the network card is just built into the motherboard. We saw how to obtain a connection. We used DHCP. It just worked out automatically. We can't go into really configuring the router. That's beyond the scope of this video. We can go into configuring client and network options. If I minimize this and I go into My Computer, right-click and go into Properties, here I can go into Computer Name. So this computer name, this is like my computer's identification on the Windows network. So this doesn't really matter for things like surfing the web or checking your email, but it does matter when it comes to sharing files across the network or sharing printers. So my computer has a name of Client 1, and I'm on a work group. I'm not on a domain, a Windows domain. I'm on a local work group. Work groups are fine for peer-to-peer file sharing in small businesses or at home, let's say. But really to connect to an enterprise Windows network, you're going to have to configure a Windows Active Directory, and this computer is going to have to be a member of a domain. So here, say I want to change my network ID. This is the Network Identification Wizard. And here, this is going to help me configure my network identification. This is where I'd configure my username and password to connect to the Windows domain. Let's stop right there, and let's go in and manually change some of these things. So this is where I would manually rename my PC. Let's call it My PC. And this is where I would go in and change from a work group to a domain. So say I'm changing to My Domain. I can go into More and set my DNS suffix. That's a little bit more advanced. Here I'd say OK, and then to join the domain, I'd have to type in my Windows Domain Administrator username and password. All right, so we learned about configuring client options for Windows Network. work groups versus domains. We looked at different network options and how to configure those. And with that, we can move on to some more configuration tasks. Now, these are taken right out of the A+ technician exam objectives. And the first one says install and configure and optimize networks. And it talks about enabling or disabling scripting support and configuring proxy and security settings. All right, so let's give that a try. If I go and open up my Internet Explorer, I can go into Tools and then into Internet Options. Now it's in here that I'm going to configure my security, including scripting, and as well as my proxy server. So if I go to security, Internet Explorer has the concept of zones. So here I have the internet zone, the local intranet zone, or the local network. I have my list of trusted sites, and then I have restricted sites. So by default here we're on the internet zone, and down here I can configure these. I can use these pre-configured levels to change groups of settings. Or I can go in and I can configure custom levels. For example, if I went down here, we can find things that have to do with scripting. For example, allow scriptlets. Right now that's disabled. Binary and script behaviors, enable or disable. Video animation, ActiveX controls. Initialize a script ActiveX control. Run ActiveX controls and plugins. Script ActiveX controls marked safe for scripting. Let's see, what else? Script initiated windows. There are just, as you can see, there are just a ton of settings in here. Oh, here's scripting, even more on scripting. Active scripting, programmatic clipboard access, websites to prompt for information using scripted windows, scripting of Java applets. So this is how you would configure custom Internet Explorer security settings. But for ease of use, by configuring the groups right here, you're configuring groups of settings all together at once. So that's how you would configure the internet zone. Then you have the trusted intranet, which you would think would be at a lower security setting. Then you have trusted sites, which might be at a very low setting because you trust them completely. All right, then you have privacy. This is where you go in and you set your privacy settings. Here's a pop-up blocker. Let's go into connections. Now to configure a proxy server, you'd go in here to your local area network connection settings. This is on the connections tab. I would click on LAN settings. And right here, this is where I would check to use a proxy server. Now a proxy server is a server on your network that will go out to the internet and retrieve something for you and bring it back. So it does this on your behalf. And it might do it to speed things up. It might do it for content filtering. It might do it for authentication and logging. A variety of different reasons are out there that you might use a proxy server. Some companies use them, some companies don't. But it can be very useful, like I said, for a variety of different things. But you would have to go into each Internet Explorer browser and configure this proxy server setting tab. All right, so we talked about browsers. Sharing network resources. Let's move on to that. I'm just going to touch on that briefly because I'm going to go into more detail on it in the security video. So basically, to secure network resources, if I go to my C drive, and let's say that I have this folder here called virtual machines. If I right-click on that, I can go into sharing and security, and then I can check to share this folder. At this point, I can say OK, and then everyone has access to this folder. It's that easy. As long as they know my computer name, they know the share name, they can get in, they can access this folder. But if I want to configure permissions on the share, I can go in here and configure more than just everyone to have read. Maybe everyone needs full control. Well, that's pretty insecure. So I can say add, and I could add just myself and give myself only full control. And I could say remove everyone so that not everyone can access my shared virtual machines folder. Then you have local network or local NTFS security. So there's a difference between share security and local NTFS file system security. And we'll go into more detail, like I said, on that in the security video. All right, so we talked about sharing. I want to point out that some operating systems have a limited number of shares that they can create or that people can access at one time. For example, Windows XP has a limited number compared to, say, Windows 2003 Server, which is designed to be a centralized file sharing system. All right, then there's tools and diagnostics. So here's some command line tools that the CompTIA organization says you should know how to use as an A+ technician. So let's go give these a try. All right, the first one is ipconfig. So if I type ipconfig, I get a list of all my Ethernet addresses and IP addresses. And specifically, let's see, here's my local area connection. This is the one that we configured before, my Ethernet local area connection. There's my IP address, subnet mask, and default gateway. Now, ipconfig has a number of options. If I type ipconfig/?, you can see I can do ipconfig/all, ipconfig/renew, release. I can do flush DNS, register DNS, display DNS, show class ID, set class ID. And we saw how we used flush DNS and register DNS a little bit earlier in this video. And the ipconfig/all will not only give you your IP address, subnet mask, and default gateway, but also your MAC address for Ethernet and DNS server information. All right, the next one is ping. Ping is a utility used to test connectivity. So say I want to ping a website to see if it's really up. I can type ping and then the name of the server, the web server, or I could type ping in the name of a computer on my local network. This sends packets across the network. Those packets are replied to, returned back to you, and the statistics are provided on the amount of time it took to transition the entire network and back. So here you see it took 93 milliseconds for the first ping, all the way up to 125 milliseconds for the last ping. And the greatest time that it took was for the third ping, which was 156 milliseconds. There was no packet loss, so there were no packets lost on this test, and the average return for a ping packet was 118 milliseconds. Now, another tool that allows us to test network connectivity is traceIRT. This is an abbreviation for trace route. So you're tracing the route through the internet that this test traffic is taking. So if I type traceIRT or traceroute, www.trainsignal.com, and press enter, it goes through my local router, which is this IP, then to my internet service provider, across to another piece of equipment on my internet service provider's network. Let's see, it just keeps on going through my internet service provider, and what it's looking for is this IP address right here of the trainsignal.com web server. And eventually it may get there. You can see how it goes through different hops on the network. Notice that this is Dallas, Texas is the abbreviation there. These are probably switch ports on those routers or switches that it's going through. Then it goes through AT&T's network. Let's see, more AT&T networks. And then it goes to this web space here, rack space. And then finally, it gets to this IP address of the trainsignal.com web server. Now, that's not how long your traffic takes to get there, because you're not testing every network connectivity point along the way. But that's how long it took for us to test every point along the network to get from here to there going through the internet. So it's pretty amazing to do this. You can do this on websites that are around the world, and you'll see your traffic being tested through major cities and major internet service providers around the world. All right, the next utility here is NSLookup. NSLookup is a tool used to look up name servers or resolve names to IP addresses. So say I type in NSLookup and then I put in the name of a web server or a host. It goes to my local DNS server, which is listed right here, this IP address, and then it does a DNS lookup and it comes back with this IP address. So it tells me that's the IP address for this web server. Let's try another one. So here, this web server has two different IP addresses that will respond to the www.google.com domain name that I provided. All right, then there's cable testing devices. These are devices that go at the end of Ethernet cables that will test the continuity. They'll test the impedance, any sort of interference that might be occurring on that cable. They'll also tell you the distance and if there's any breaks in the network cable. Some of those are fairly inexpensive, and on the other hand, they can go all the way up to $5,000 on up to $10,000 for high-end cable testing devices. Then you have diagnosis and troubleshooting of drivers and network interfaces. Well, I mentioned lights that were on the outside of my network interface. Those are the most basic diagnostic and troubleshooting tools you can use on your network interfaces. But many times network adapters will come with their own tools that you can install that can be used to test network connectivity with that network interface card. All right, we talked about protocol configuration, configuring IP addresses, default gateways, subnet masks, DNS, WINs, and then using static versus automatic IP address assignment with, say, DHCP versus statically defining your IP address. We talked about IPX and SPX and how these were used with Novell NetWare in previous versions. We showed you Windows file permissions. To configure Windows Firewall, you go into your network adapter, or you can go into Settings, Control Panel, and there's an icon here for Windows Firewall. I can go in here and I can turn it on or off. I can allow exceptions, or I can configure logging. So that's the Windows Firewall. It's a very basic firewall. You can, of course, buy more advanced firewalls for your computer, or you can buy network firewalls that protect your entire network. You can't have electrical interference on network cables. That's why people recommend you don't run network cables near fluorescent lights or other sources of electromagnetic interference. Now, when it comes to performing preventative maintenance, we'll be talking about this in a little bit as far as preventing problems on your network. But when it comes to your network cabling, of course, you want to make sure it's secure. You want to make sure your wiring closet where your switch is locked. Make sure you don't forget physical security. Lock that stuff up so people can't go in there and start plugging or unplugging network cables. And then lastly down here it talks about identify tools, diagnostic procedures, and troubleshooting for status indicators. We talked about lights both on our switch and on our network interface card. We talked about the speed of our network interface. When I went into the status, you could see that it was running at 100 megabits. If you don't have a quality network cable or connection, or say your switch that you're plugging into isn't 100 megabit, say it's a 10 megabit, you're going to get the lowest speed of the devices, meaning the network interface card or the switch or the hub that are on your network connection. So if you have a 10 megabit network card and a 100 megabit switch, you're only going to be able to talk at 10 megabit. There's activity lights both on the switch and on your network interface card that you can see whether or not you're sending and receiving traffic. And then when it comes to wireless, let me show you my wireless network interface card. You can see here I have a signal strength indicator just like you would have on a cell phone. And this shows me how strong the wireless signal is. So if I took my laptop and I moved it around my office, or maybe I went outside, you could see that my wireless signal strength would go down and I'd eventually get disconnected. I can also go in and view the wireless networks that are available. You might have a number of different wireless networks available in your area. You can see some of these other wireless networks have lower signal strengths than the wireless network that I'm connected to. All right, when it comes to configuring browsers, we went into our web browser and I showed you how to configure security and also proxy settings. When it comes to sharing network resources, I showed you how to configure a share. But here's a few things I want to point out. There's a number of different models when it comes to sharing network resources. You might share your resources in a peer-to-peer model. So this would be just between, say, your PC and another PC, and both of your PCs are peers, or they're equals to each other. On the other hand, you might have a client-server model. So maybe you have a dedicated file server, and all your 50 PCs are sharing files off of that one file server. You could use a domain or a work group. We talked about that, how to configure my PC to join the domain, and how I'd have to type in the Windows Administrator password. We talked about the difference between shared and NTFS permissions. And I want to point out the most restrictive of the two applies. So if NTFS permissions have deny, so that someone is denied access to that file with NTFS permissions, that's more restrictive than maybe the everyone is allowed full control with the share permissions. So the most restrictive of the two applies. Now with share permissions, you can configure read, change, and full control access, but with NTFS permissions, you can get much more granular, and you can configure read, write, list, modify, read, execute, full control, and many other settings. Now, when you're sharing a file or folder, it's easiest to share or to use share permissions and set those to full control for all authenticated users, then use NTFS to get more granular. Something else I want to point out, we talked about how certain versions of Windows have limitations on the number of shares they can provide, and an example of limitations when it comes to networking is Windows XP Home. With Windows XP Home, you cannot join a Windows Active Directory domain. So if you have a company and you have a Windows 2003 server, and that's your domain controller, and you create Active Directory users, and you want your Windows computers to be able to log in using those Windows usernames and passwords to the network, you're not going to be able to do it with Windows XP Home. You're going to have to upgrade to Windows XP Pro. All right, we already went in and we configured our share and NTFS permissions, and so we can move on. All right, now let's review some of the network troubleshooting tools, most of which we've already talked about. We talked about ipconfig. You'd use this to show your IP address, default gateway, subnet mask, DNS servers, and the status of your network adapters from the command line. We talked about ping and how it would be used to test network connectivity. Now, we didn't test path ping. Path ping is similar to ping and similar to traceroute. Let me show you how it works. Path ping, www.trainsignal.com. This goes through and it pings all of the routers or all of the devices along the path to get to the website that I provided. So it pings every one of those, and then it computes statistics for all of these different hops along the internet path to get to the website. So that's ping path right there. And it's still not done computing its statistics, but I'm going to press Control-C and break out of that, and we can continue. We talked about tracert. Tracert, again, used to test the path through the internet or through some network to get to some destination. We talked about NSLOOKUP, used to perform name to IP address resolution from your DNS server. Find out what your DNS server says is the IP address for a certain computer name or web server. We talked about a cable tester and how it can be used to test Ethernet cables. We didn't talk about a protocol analyzer. A protocol analyzer is a piece of software you run on a computer that analyzes the network. It's that simple. It looks at every packet, every piece of information going in and out of your network adapter and analyzes that data. So it tells you how much bandwidth you're using, what sort of applications. It can even look inside the packets and tell you the text or the pieces of data that are being sent or received. It gets very detailed. It can get very complex. You can download a free protocol analyzer by going out to your favorite search engine and typing in either Ethereal or Wireshark. It's pretty much the same protocol analyzer. It's been renamed, but it's a great free protocol analyzer that can tell you more information than you ever wanted to know about your network. It's also great for troubleshooting network problems. So we talked about some of the common troubleshooting tools. So now let's talk about some of the common troubleshooting network issues. So say you're having a problem with your network interface. It could be your driver. You might need to look at that. Or you might just have a problem with your cable or the connectivity back to the switch. Maybe the switch is powered off or broken, or that port is disabled. So to know that, you can check your lights on your Ethernet adapter or back on the switch. You might have problems with your TCP/IP network settings. You might have the wrong gateway, or you might not have a gateway. You might not have the right subnet mask, DNS, WINS. You might not be getting an IP address at all from a DHCP server. All things to look at when it comes to troubleshooting network problems. IP configuration is one of the most common network issues that you'll run into. Firewall configuration. Maybe your web browsing works, but you can't seem to FTP or listen to music over the internet, or you can't run your peer-to-peer file sharing or do your instant messenger. So you know that some applications work, but other applications don't. This is commonly pointing to a firewall configuration issue. Maybe the network administrator for your network has locked those things down, or maybe your firewall just by default only allows web browsing. You know, something to look into. Electrical interference. Say things are running really slow. One of your network cables doesn't seem to work. One of the jacks in the wall doesn't seem to work at all, or sometimes it works, sometimes it doesn't. You could have some kind of electrical interference on that network interface cable. Wireless signal strength. Obviously, just like a cell phone, you have to have a good wireless connection to get a good signal and talk to the wireless access point. But the better signal you have, the better throughput you're going to get. So say you're doing a file transfer over the wireless network, the more signal strength you have, the faster you're going to get that file. So now let's talk about preventative maintenance of networks. Now, without the network, there are no network applications. So preventing network downtime is crucial to any organization. So without the network, you don't get your web browser, you don't get your shared files, there's no email, there's no streaming music, there's no downloading games, there's no running your enterprise financial application or accessing your critical data. All those things are gone without your network. So some things you can do to prevent your network from having downtime are you can inspect your cabling, and you can have your cabling organized. So if there is a problem, you can go find the right cable that needs to be connected or disconnected. Many times network downtime is caused by disorganized cables. People get frustrated, or maybe they are misinformed and they pull the wrong network cable, causing the whole network to go down. You can schedule network changes during a maintenance window. Don't make network changes during the day. If you need to reboot your router or do a firmware upgrade on your router, for example, that's something you should be doing during a maintenance window at night to prevent network downtime. Keep a log of network changes. Say you did do a router upgrade and then a week later you start having problems. Well, when was the last time you upgraded that router, and what version did you go from and to? Well, if you had a log, you can go back and look those things up. You should test network changes before you implement them. So have a little test network. If you're going to do a router firmware upgrade, or you're going to re-IP address your network, test those changes before you implement them. Keep your router and switch operating system up to date. There's a lot of bugs that come out, or security holes that come out for routers and switches. Keep your operating system patches and your antivirus virus definition files up to date. There's a lot of security holes, again, that come out for operating systems and antivirus software. Next, you should develop a network baseline, and you should monitor network performance. So say the network's running really slow today. Maybe you bring up a protocol analyzer. Well, what's normal for your network? How do you know if this is normal or not? And if there's a bunch of some type of traffic on the network, is that normal network traffic or not? Well, if you've never looked at your network before and you've never done any kind of analysis, the first time you have trouble, you're going to have problems trying to determine what is causing the problem, because you don't really know what's a normal occurrence and what isn't. So a baseline is analysis of your network and then documenting what type of protocols, traffic, bandwidth, and connectivity are available at the time of the baseline, so you can use that for a comparison later. And then make sure that you use quality hardware and cabling. I recommend buying network cables and having professionals do wiring in your business or your office to make sure that you're using quality equipment. Make sure they use cable testers, and every jack that they install in the wall, they test and they give you a report of the quality of that network cable. If you start using poor quality hardware and poor quality cabling, you're just asking for trouble. You're asking for downtime, unreliability, and poor performance. Now, say you get past your A+ certification, which I know you are, and you're interested in networking. If so, CompTIA offers the Network Plus certification that's similar to the A+ Computer Technician certification, but for networking. And I just wanted to point out that TrainSignal offers a Network Plus video series that can be found at our website. And finally, we've reached the end of this video where we talked about A+ Technician, networking, configuration, and troubleshooting. In this video, we learned about the different types of networking, the core network components, how to perform IP addressing, what DNS does for you, how to configure your network, configure your web browser, how to share network resources, and how to perform preventative maintenance of your network, as well as we looked at a lot of different troubleshooting tools for your network. So this has been a very exciting and interesting video covering computer networking for the A+ Technician. Thank you very much.